catchy tune.
Yeah, I know.
That's a catchy
They
tune.
did a good job with that open.
Hey, good morning, everyone. Welcome to another edition of our Weather Academy. I'm Tom DiVecchio, my cohort Craig Flint here for today. And we're going to start out a little bit here with, we talked about satellites last time. And we have a real interesting satellite.
Yeah, we just kind of wanted to quickly revisit or circle back to the last lesson, which we talked about weather instruments. And we have a really interesting scenario showing up on our satellite picture. So we're not going to spend a lot of time on this, but we just thought this would be kind of cool to show you with what's going on with our satellite picture. Remember, satellite's taking constant pictures of the Earth. And a couple of interesting things to note. You see that swirl out there? We talked about high and low pressure, rising and sinking air. That is a low pressure system, but what makes this interesting is it's almost, not quite, taking on some tropical characteristics.
Yes.
And the other interesting thing about this is look at the way it's moving. Moving west.
Yeah, it's moving toward the west. If you watch it, it goes from the right side of the screen toward the left side. Most of the time, the jet stream is usually the great, we call this steerer of the storms. But in this case, the jet stream is very light overhead, and it's actually allowing it to, we call it retrograde because it's going in the opposite or retro of what we would expect. And so it's moving to, it's actually giving some pretty nasty weather to New England right now there at Boston and those areas.
And we're far enough away from it. We may see some clouds out of it, but just kind of an interesting thing to show you. We wanted to start off and kind of revisit what we discussed with satellite and show you a really interesting satellite shot and something that you don't see every day in weather. So we've talked about what we do as meteorologists. We've talked about weather instruments. We've talked about high and low pressure, wind direction, kind of all the basic building blocks.
Got the tools down.
What we're going to do today is we're going to peel another layer of the onion off, and we're going to start to actually get into some science and meteorology.
I love onions.
Yeah.
I love onions. I do.
The thing is, what we're going to talk about today is the water cycle. We both have our water here.
Yes.
And this is not only essential to life, but it's essential to weather. So here's to you, Tom.
Here's to you, yes.
Cheers. Go grab yourself a bottle of water or a glass of water and settle in, because we're going to talk about the water cycle and where water goes, because here's the thing about water. It's never destroyed. So if the Earth is something like 4 billion,
about 4.5 billion
years old.
I heard, yeah.
So it is conceivable that this water and the water you're drinking was around when the dinosaurs were here.
Exactly. Very, very good possibility.
Very good possibility. So where does water go when it goes down the drain? Or, it goes away from you, but does it really go away? And the answer is no, it doesn't.
No,
we constantly, now this will go through changes, both changes of state, and then in cases of like drinking water, it's purified, it's cleaned.
Right.
But we always reuse it. So water is never going away. So that's why it's so important to not only life, but to weather. So that's what we're going to delve into today with the water cycle.
Absolutely. And I forgot what the next graphic
we have
is.
the graphic.
Yeah, we have the water cycle here. Yeah, and the water cycle, for most of you kids, you probably, if you're like third grade on, you probably have learned about the water cycle. But let's pop it up full screen here. That's good stuff. Yeah. But, and the water cycle, what is a cycle? I mean, a cycle is something where we have a certain plan or a certain happening, in this case in the atmosphere, where we start at one place and we go to another place and then we go back to where we originally started. That's what a cycle is. It starts out and so where does water, well, water starts here on Earth. But we know that rain and snow, clouds, are up in the sky. So what happens? How does the water go from water on the Earth to water in the sky?
Yeah, so that's what I was asking earlier. Like, where does this water go? Say you have a puddle in your driveway in the morning when you go to work, and then when you come home, it's gone. Well, it didn't just go away. And one of the key things of the water cycle, and we talked about this a couple of lessons ago, is our favorite yellow star, the sun.
Absolutely.
So the sun heats the ground, And there are really, this can get a little complicated, but what we're going to focus on are just kind of the main points here. Evaporation, condensation, precipitation. Those are the three key words that you'll want to take away from this lesson. So as the sun heats the surface of the earth, the water undergoes evaporation. It changes state and it goes back into the sky.
Right, it goes from a liquid to a gas, a liquid that we can see to a gas that we can't. And that's actually on Craig's side. He's got the evaporation side. If you watch, see that little arrow going up there and the word and evaporation. And that once it gets up there, kind of the reverse happens. So we go from evaporation to condensation. As the air rises, it cools. Now, cool air gives off water vapor more readily than warm air. Can't hold it as much. So it condenses. Very similar whenever you go to your favorite restaurant, or maybe you're pouring a glass of iced tea into a glass. What happens on the outside of that glass? It gets wet. Well, is the tea seeping through? No. Air that has water touches that colder glass, and the water vapor changes state again from a liquid, from a gas back to a liquid that we can see, and what you see there is clouds. That is simply condensed water vapor that we can now see with our eyes.
Yeah, and those clouds continue to billow up and they get tall in some cases. We're going to talk about the different type of clouds coming up in future lessons, but basically what happens is there's some element of gravity involved with this as well. So as those clouds grow, eventually it almost gets too heavy. And it has to fall to earth. So the groundwater that was in your driveway in the morning, during the day, with the sun heating the surface, went back into the sky. It cooled and condensed, like Tom was just saying, formed a cloud, and eventually that cloud has to rain. So the water that was on the ground went back into the sky, and now it's going to come back down to earth.
And that is
circular motion.
That's the cycle. We start out with water on the earth, evaporates, goes into the upper atmosphere, condenses in the clouds. Clouds get heavy, get thick. Precipitation, like rain or snow or others that we're going to talk about in just a second here. And it goes down mountains, goes into rivers, streams, into the land, into groundwater, back down to earth. And the whole thing starts all over again, just like it has for the past 4.5 billion years.
Pretty crazy to think about. It's pretty crazy to think about. So yeah, you get the key terms here: evaporation, condensation, precipitation. There's also collection in there too. But basically, again, when we were talking about math a little while ago, again, this is kind of a complicated math equation, but the simplest version of this is evaporation, condensation, precipitation. So as that water collects in the ground, the sun heats the surface, which causes the evaporation, and it goes up into the sky. You get the condensation, the clouds, and then the precipitation, and we just keep going round and round we go.
Absolutely. So, speaking of precipitation, there are many kinds.
Many kinds. So water is important to life and weather, and we should always be mindful of that.
Hydrated.
Yeah, stay hydrated. Hope you're drinking a nice cold glass of it right now. So, let's talk a little bit about precipitation. We've kind of covered the basics of the water cycle, how it works with the evaporation, condensation, precipitation. When we say precipitation, what exactly do we mean by that? Well, it's anything that really...
anything that's water,
right.
types of water that falls
from the sky.
Naturally. If I go up with a bucket of water and drop it, that's not precipitation. Okay. Nature has to put it there, and then it has to fall.
Right. So the first one we'll talk about is rain.
Yeah.
Let's take a look at this, and basically everything has a definition in meteorology. So rain is a form of precipitation that falls to earth and drops more than 0.5 millimeters in diameter.
Okay. So you're talking about, we have 25 millimeters to an inch, okay? So 0.5 is very small.
Very small.
Very small. Maybe a tenth of an inch or a hundredth of a tenth of an inch if I'm doing my math right here. But and rain comes in many sizes. Sometimes it drops.
Right. And we don't want you to get hung up on those numbers there.
Yeah.
That's just the definition that is what rain is. That's what the definition is what rain is defined by. So need the umbrellas for the rain, obviously. We got 2 of them there. Next up, we want to talk a little bit about the other one.
Yes.
Snow.
And again, like Craig said, everything has an official definition. And while we want to have fun here, we need to, want to help you learn a little bit here. So precipitation in the form of ice crystals. And the key word here is crystal. They are hexagonal in shape. That means they're 6-sided. And they are often collected into snowflakes, formed directly from the freezing of water vapor in the air. And it freezes. Water vapor freezes into a crystal, and again, we can't want to get too caught up in the science. Bigger drops freeze into ice. Water vapor freezes into crystals, and these crystals sometimes form together, and that is the snow that you see. And they say no 2 snowflakes are exactly alike, and that is the case because there are almost an infinite amount of 6-sided crystals that you can find.
Yeah, these guys are really interesting. Now here's a little tidbit about snow. You can come back to us on camera. You heard Tom mention crystal, okay? Did you know that snow isn't actually white? If you blew up a snowflake in a microscope, it's clear. You'd be able to see right through it. So what happens is as these snowflakes collect with each other, they all get together and have a little party, okay? And what that does is, now help me with the terminology here.
Okay.
Bends or refracts the light?
It will refract.
Refracts the light. And that makes it appear white to your eyeballs. To you and me, snow looks white, but actually it's not white.
It's right, it is clear. It's a similar type of science to rainbows, which maybe we can talk in a future segment as well.
Sure will.
But yeah, refraction of light is what it does. Light is all the colors of what we call the spectrum. And when it goes through a snowflake, it bends and it splits those colors. But in this case, well, I'm sorry, that's with rain. With snow, it doesn't split the colors. It still keeps it as white. But keeps it as all the colors, which is white, and that's why a snowflake appears white when you collect them all together like that.
Yeah,
that's exactly.
So pretty cool little factoid there about snow. It's not actually white. Pretty neat. All right, let's move on, and we'll talk a little bit about sleet. Now, this is important because not only for the kiddos watching, but even some of the parents, because I hear this all the time. When we have sleet in the winter, people will come up to me all the time and say, hey, Craig, it hailed today. Here's the important qualifier. Sleet is not hail. It's not hail.
That is correct.
That it forms totally different, and we're going to delve into that a little bit. But let's show you what sleet is. So these are little ice balls. And frozen or mostly frozen raindrops or refrozen, partially melted snowflakes. And the best way you could tell if it's sleet or not is when it hits the ground, it bounces.
Right.
It bounces across the ground. It bounces off the car hood and the windshield. So that's probably the easiest way you could tell if it's sleet versus hail, which we're going to get into next. But sleet, again, little frozen balls of ice that bounce across the ground.
That's right. You hear it tapping on your window, like if you're asleep. If it's tapping, that tap, 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 it's sleet. Rain is more of a kind of a slushy type of hit.
And real quick with sleet, I dropped my clicker. With sleet, what happens is it's a raindrop that will fall into a layer of freezing air.
Right.
That's substantially thick enough from the surface up to a certain height, where it will actually start to freeze again. And that's what sleet is. So it's, like we said in the definition, it's a partially frozen or frozen raindrop.
Exactly. It'd be the same thing if you fill an ice tray with water and you put it in the freezer. Well, what does that turn to? Does it turn to snow? No, it turns into ice.
Ice,
and that's what's happening here in the atmosphere. Now, sometimes the layer can be very shallow. Maybe even as tall as the trees, this shallow cold layer that's below freezing. So when those raindrops fall into the shallow layer, they don't have time to freeze into ice balls before hitting the surface. So they'll hit the surface, and they'll freeze on that surface, and that's what we call freezing rain. And that's what's different from the sleet bounces. Freezing rain does not. It falls as rain, and then it forms a layer of ice on the surface that it falls.
Yeah, bad stuff.
Very bad.
Bad stuff.
To me, it's the worst wintertime precip ever is freezing rain.
Yeah.
Give me a foot of snow any day.
Yeah.
Freezing rain,
Not,
no thank
not
you.
good. So if there's one thing I want you to remember about sleet is that it is not hail, okay?
Right.
Speaking of hail, let's explore hail. And let's bring this up full because how this forms is totally different, right?
Yeah, indeed. And hail is similar to sleet only in that it is ice. But as you can see, it's balls of ice that's more than 5 millimeters in diameter. And balls of ice is kind of, sometimes it's round, sometimes it's like an onion, sometimes it's got all sorts of weird configurations. It can be as large as grapefruits, as small as pea-sized hail.
It can be huge.
Now, the way it forms, we want to come back to us here. The way hail forms is different. Hail only occurs in what we call convective events like thunderstorms. And what happens is you have thunderstorms have trillions and trillions of water droplets, and they're all different sizes. So, and thunderstorms have what we call updrafts, that's winds that go up, and downdrafts, where wind comes down. Now, at the top of a thunderstorm, temperature can be 30, 40 below zero.
Yeah, cold.
It's cold. So if you get an updraft that takes this area of water, and that updraft puts it up into the upper part of the atmosphere, and it kind of hangs there, and it turns into ice. Well, now it falls. Now, ice is sticky. In other words, as that ice ball falls, so we have this ball of ice, little water droplets from other raindrops start to form around it and form another layer into the lower part of the storm. Here comes another updraft.
Catches it, and it goes up.
It goes up.
It rains up.
Yes.
How
it literally
weird
goes
is
up.
that?
Updrafts can go 50, 60, 70 miles an hour.
Yeah.
So we can go up. Now it goes up to the top of the thunderstorm. Now you have your ice, and then that layer of water freezes, goes back down, goes back up. It might do this 6, 7 times.
Yeah.
So what happens if you split a hailstone, and it's a stone, it's called a hailstone, it looks like an onion.
Yeah.
And eventually it either gets so heavy that the updraft can't hold it, or a downdraft will literally...
Gravity kind of takes over.
Right, gravity takes over. And that's how a hail...
So the big takeaway, sleet is not hail. Hail is formed totally different. It has to fall from a cumulonimbus cloud.
Right.
Okay? And one of the cool things about hail, as we get close to quitting time here, safely, of course, safely, if you can, once the thunderstorm passes and it deposits hail, you mentioned the updraft, how it goes round and round inside that thunderstorm. If you can get out there safely after the thunderstorm passes and you can collect the hailstone and you cut it in half, like you said, you see those rings like an onion or like a tree. And if you count those rings, that's the amount of time that hailstone went up and down, in that thunderstorm. Pretty cool stuff.
Yeah, now, it probably won't work with the pea-sized hail. You'd have to have...
It has to be substantial size.
You'd have to be, which unfortunately is usually with severe weather, so you're probably going to stay in anyway.
Yeah, you want to stay in.
But definitely be safe. Do not go out when in the middle of the storm. That's not smart. Don't do that.
And some of the hail, like the hailstorms like they get out in Texas and the Plain States, can literally accumulate on the ground.
And they look like a snowstorm sometime. And
Yeah.
real nasty.
And they can be very damaging too, hailstorms. Now, you got insurance claims and busted windows and sidings on houses. Yeah.
Right. And some of you who live in Crawford County may remember just last year about this time. It was right around Easter. We had 2.5-inch hail in Crawford County. Many of you sent us your pictures, and it was very damaging indeed.
Yeah. All right, so that's going to wrap it up. Don't forget water, okay? Most important part of weather and life. So make sure you're drinking plenty of water. It'll keep you healthy. It is one of our most precious resources here on Earth. So we got to take care of it. But just think about that today. The water you're drinking has been around since the Earth has been here.
Absolutely.
That's
4.5 billion years old.
Yeah.
You wonder where this water's been.
Where did it go? And where, well, we kind of
look at a different light.
Yeah, we kind of discussed how that works with the water cycle. We'll end today with, again, our question, our mantra here. What is inspiring you? We're hoping that you're taking away some of this stuff that we're talking about here, and maybe you're becoming more interested in weather. And that's awesome. We hope you are. We hope that we're providing you with some help in these weird times. So that was kind of the water cycle today, and you can obviously go learn more about it. National Weather Service has great resources.
Wonderful
We kind of gave you the basics of it, but water and the water cycle and how much it plays a role in weather.
Well done. Okay, that's our show for today, our Weather Academy. Hopefully you enjoyed it. Again, please email us right there, weather@wjettv.com. Let us know maybe what inspires you. Let us know what kind of questions you had about what we talked about today, or maybe some previous talks. They're all on our website. What we've done today will be posted later, and what we've shown in the past as well.
And real quick, one little note on that before we go. When you go to our website, yourerie.com, it will live under the weather tab. So just hover over weather at the top of the page. You'll see the drop down come up and you'll have the choice for Weather Academy. These will be posted later this afternoon. So with that, email us your questions, and remember, what inspires you? Let us know. Drink plenty of water.
Stay hydrated.
Stay hydrated, stay healthy, and we'll see you Monday.
Thanks for joining us.